All right, we are in Algebra 2, Lesson 63. Is that right? Algebra 2, Lesson 63, page 447. So I'm going to try to do some typing up here. I usually like to have this stuff ready before we start, but it's been a busy day. So I'm all kind of discombobulated. What we're talking about today is understanding the unit circle and radian measure, or measures. All right. Unit circle. What is that, Ronnie? What is the unit circle? Is a circle with a radius of 1 unit. We're not, and this is going to be drawn on a coordinate plane. Okay? And let's see, we do have a box on page 448 that is going to tell us how to convert radians to degrees. Okay, and it's going to be a lot easier for me to draw this up than to try to type it up. But converting, if we have degrees, we have degrees, we want to convert from degrees to radians. Okay, if you look in your calculator, if you go to mode, you're going to notice that there are two things. You can either have your calculator in degree mode or you can have it in radian mode. Most of the things that we do, we want to have our calculator in degree mode, and you've probably heard me say that before. Check and make sure that we're in degree mode if we're working with degrees. Okay? So if we have degrees and we want to convert to radians, we're going to take our number of degrees and we're going to multiply it by pi and divide it by 180 degrees. Okay? So our number of degrees times pi divided by 180. So let's go ahead and practice that here for a second. Let's pick something really basic. Let's say we have 20 degrees. Okay? We're going to multiply it by pi and divide it by 180. What is 20 times pi? Anybody? What's 20 times pi? Don't give me a number. What is it? No, don't give me a number. It's 20 pi. Okay, because radians are going to be in terms of pi. Okay, radians are a fraction or a whole number in terms of pi. So 20 times pi is 20 pi. 20 degrees times pi over 180 is 20 pi over 180. Okay, now, can I simplify 20 over 180? Yeah, what is it? 1/9. Okay, so we could write 1 pi over 9, or we could just write that as pi over 9. So the degree form, or sorry, the radian form of 20 degrees is pi over 9. Does that make sense? Okay, so you want to be able to go back to this slide and do that same thing, and we can do that with any degrees. Okay, now it may be a complicated fraction, it could be a mixed number, okay, an improper fraction, but it's always going to be in terms of pi. All right, so let's go on to our next slide, where we're going to talk about converting from radians to degrees. And this is a fair shot easier, okay? So we're going to take our number of radians and we're going to multiply it by 180 divided by pi. Okay? And the reason that 180 and pi are there is because we're getting an equivalent, and pi is equal to 180. Okay? So this is essentially like multiplying by 1. Okay? All it's doing is changing the form. Okay? So let's go back to that other question, right? Which our answer was pi over 9, right? Right? Okay? And let's multiply it by 180 over pi. Okay? Well, what happens to those pi? They cancel out because I've got a pi on top and I have a pi on the bottom. And I will always have a pi on top and a pi on the bottom when I'm converting from radians to degrees. So what number was next to that pi, though? 1. So this is really 1/9 times 180. And so what that's going to do is that's going to be 180 divided by 9. Well, what's 180 divided by 9? So I got the 20 degrees back. Okay? Now, if you want a shorter way to think about that, take the fraction of your radians and multiply it by 180. That's always going to be your degrees. Okay? But this is kind of the long way of looking at it. Does this make sense? Can we do this? Okay? Now, the only other thing that's really in here, okay, let's see, we'll look at some other things, but in terms of what we want to cover before we leave, is arc length formula. Now, arc length formula is something that we've already talked about, okay? I believe we've talked about it, but we didn't talk about it in here, we talked about it in geometry. Arc length, okay? That is the distance of the arc from here to here in units, okay? Now, because it's a length of a circle, how do we find the distance around a circle? What formula do I use? What's the name of the formula? What's that? No, it's not pi r squared. What does pi r squared find? No? Pi r squared doesn't find circumference. What does pi r squared find? Area. But what do I want? I want, you were right, I want 2 pi r, which is circumference, right? So I want 2 pi r, because I do want to find a length around a circle. Do I want to find the entire length around the circle? No, okay? I want to find a fraction of that length. Okay, so that is going to be the measure of this arc in degrees over 360. That's how I'm going to find the length of an arc. Okay? And these will be the same thing. The number of degrees here and the number of degrees here will be the same because it's a central angle. Okay? Central angle and its intercepted arc are the same. So if I know the central angle, or if I know the intercepted arc angle, right, it's the same thing that's going to go in here. Okay? So let's say that I knew that my intercepted arc or my central angle was 60 degrees, and I knew that my radius was 2. Okay, or let's make it different so it's not confusing. Let's make it 6. What I would get for my formula is I would get 2 pi 6, and let's call that 60 degrees here. I would get 60 over 360. Well, 2 times 6 is 12, so I have 12 pi, and 60 over 360 is 1/6. So I would get 12 pi over 6, which is 2 pi. Okay? So the number of degrees there, okay, I can either leave that as 2 pi. Let's see. I think I can leave it just like that. Okay, and that would be 2 pi units. Okay, or I can actually multiply that by 3.14. Okay, or the symbol for pi in my calculator and find out what the irrational number is going to be. Okay, it should come out to almost 8. Okay. All right. Do we understand how to find the length of an arc? All right. Let's go from here to actually working out some problems. I don't know if I've got this pulled up already or not. It doesn't look like it. So let's, and we want 63. You okay? Okay. All right, here we go. Let's convert 4 pi over 5 radians to degrees. So this is what I wanted to tell you, that what we can do to make this a little bit easier is just substitute 180 for pi in that fraction. And what that's going to look like is 4 times 180 divided by 5. Okay, what's 4 times 180 divided by 5? 144 degrees. Okay, I think that is a quicker way of converting from radians to degrees, is substitute 180 in for pi and solve. Okay, so let's make sure that we're writing that work down. Be a little bit easier for us. Okay, number 2 is where we're going to get into the unit circle portion of things. Okay, so you want to pay close attention to what we're going to do here. Can I erase number 1? Yes? Okay. All right, so I'm going to go over, you guys should have this page sent to you, right? So you guys are looking at that. I'm going to come over here and we're going to do this. Okay, we're going to make a coordinate plane, right? And what we need to remember is that this is 90 degrees, this is 0 degrees, this is 180 degrees, and this is 270 degrees. Does this ring a bell? Do we remember this? All right, this is my initial side, correct? Yes? All right, what we're trying to find is the exact value, the trigonomic ratio, cosine 135 degrees. Okay, so my terminal side is in which quadrant? 1, 2, 3, or 4? If it's cosine 135 degrees, which quadrant am I going to be in? 2. So my terminal side is here, correct? Yes? Okay. So what we're saying is that from here to here is 135 degrees. Now, what I want to do is I want to use the unit circle to finish this triangle. Now, if this is 135, what is my reference angle? Anybody? No? What's my reference? The reference angle is the angle from my terminal side to the x-axis. 45 degrees. Okay? If that's 45 and this is 90, what is this angle right here? 45. Have I lost you? Is anybody lost? Yes? Okay. Do you understand how we got to this line right here? Okay? Now, we are making a special triangle between my terminal side and the x-axis. Do you get that? So you understand the 45, right? This is where we're going to put our reference triangle. Do we get that so far? Do you understand how we got the 45? Okay? If this is 135 from here to here, and this is 180, the reference angle is always the remaining number of degrees that are going to get me to the x-axis, or even the numbers that I got to go back. So 135 plus 45 equals 180, okay? Which is going to give me a 45-45 special right triangle. Now, because this is a unit circle, when you go back and you look at your definition of what we talked about, it said a unit circle is a circle with a radius of 1 unit, okay? So what we're talking about when we talk about this unit circle is that everything is done around 1. So what is this length right here? It's 1. Okay, now I didn't do a very good job of drawing it. If I did, it would come around like that. So this is 1. Let me clear this up a little bit. Okay, so my length here is 1, okay, because it's a unit circle. All right, and because it's a 45-45 right triangle, I have a very specific ratio, right, which is x radical 2, correct? We've learned this. I know it was a long time ago. All right, which is why this side is 1, correct? What's my hypotenuse? X radical 2, so it is 1 radical 2. Okay, now what they wanted me to find is the ratio of cosine 135 degrees. All right, so we're always going to base that off of our reference angle. Cosine is what? Cosine is adjacent over hypotenuse. What is adjacent to that angle there? 1. Okay? What is hypotenuse? 1 radical 2, or even just radical 2. Can I leave it like that? Somebody said sure. Can I? No. What do I have to do, Lexi? Multiply by radical 2 over radical 2. What is 1 times radical 2? And what's radical 2 times radical 2? 2. Now, the other thing that you have to remember is because we're dealing with a coordinate plane, that one was negative. Okay? So this one was negative, so that is a negative radical 2. So my answer is negative radical 2 over 2. I know that we're going to struggle with this. Okay? I fully expect tomorrow to answer a bunch of questions about this. Okay? Okay, the only way we're going to get better is by practicing and trying. Okay? I'm guessing, how many of you feel lost? Okay, a handful of you. All right, so let's try to do some more. All right. Let's see. Hopefully you're reading it, because the next one says, use the unit circle to find the exact value of the trigonomic function tan negative 257 pi over 4. This is in radians, okay? So the first thing that I want to do is I want to convert those radians to degrees. What do I substitute in for pi? 180. So I'm taking negative 257 times 180 and I'm dividing it by 4. So I'm going to do that to find my number of degrees. Okay? Now it should be a pretty big number of degrees, right? Anybody have a number for me? Okay. Negative 11,565 degrees. So I'm going clockwise around 11,565 degrees. Let's do this. Let's divide that by 360 degrees to find out how many times I'm going to go around my circle. Okay, so what number did you get? I'm going to go around, and I understand that it's negative, but because we're talking about just times we're going around 32 times, right? Okay, now what I'm trying to do is I'm trying to find the exact degrees down to what I'm getting to, okay? So I'm actually going around 32.125 times, right? So what I'm doing is I'm starting here and I'm going around once, twice, 3 times, 4 times, 5 times, 32 times. What's really important to me is that 0.125 that's left, okay? So what I'm going to do is I want to find out what that is, okay? So in order to do that, I'm going to take 32 times 360, which is what? Well, it's 11,520 degrees. So if I want to find out what's left, I'm going to take 11,565 and I'm going to subtract 11,520. And what I'm getting is I'm getting a remaining 45 degrees. Do you follow me? Did I lose you? Okay, so that 0.125 represents a remaining 45 degrees. So as I come around here, what I'm saying is I'm going around this coordinate plane 32 complete times and another 45 degrees. Do you follow that? Okay, so that's bringing me down here where this is 45 degrees, which means this is 45 degrees, which means that is 90. Okay, do we get how we got there? Why did I go down? Because it was negative, which means that is a complete rotation, right? which means as I go around again, let's say that I went around 32 times. That's where I would stop, right? But because I have an additional 45 degrees to go, I have to keep going that direction, which is going to bring me 45 degrees into the fourth quadrant because I'm going in a negative direction. Okay? So, because this is unit circle, come on. Okay, because this is unit circle, now I need to put my ratios in here, which means this is 1, but this is negative 1 because I'm below the y-axis, right? Which means this is radical 2. Okay, so if I'm looking for tangent, tangent is opposite over adjacent, right? And I'm always basing it upon my reference angle. So what's opposite of that angle there? Negative 1. And what's adjacent to it? 1. What's negative 1 divided by 1? Negative 1. So my answer is negative 1. Okay? Did that, I mean, it's still a hard question, okay? But I do want you to try. I do want you to complete. Okay? Let's look at number 4. Now what I'm going to do is I'm not going to probably get through this entire lesson before we're done here, because what, you guys are out at what, 36? Okay? So what I'm going to do is I'm going to pick it up with the other class, 7th hour. All right? So this video is going to be in 2 parts. I expect you to watch the second part, okay, as you're getting ready to do your homework, because this will be more questions you can see. Okay? Number 4, though, I think I can finish. It says, find the arc length of an arc with a measure of 140 degrees in a circle with radius 2 around your answer to the nearest tenth. My formula is 2 pi r measure over 360. So this should be an easy question, right? I'm going to write 2 pi what? What's my r? 2. What's the m? 140. Okay, can I simplify the left-hand side? 4 pi, right? All right, what's 140 divided by 360? Is there a simplified fraction I can work with there? Maybe. But in the end, all right, what I want you to do is take 4 times, parentheses, 140 divided by 3, or you can even just type this in your calculator, right? All right, does anybody get anything? Should get 4.8869, which is going to come out to 4.9 inches. That's what you should be getting for that. So I'm going to pick it up with the other class with question number 5. All right, I do expect to see this assignment done tomorrow, okay?